but I'll start with my introduction and explaining a bit what we've been doing, the open days that we've been discussing just before, and a little bit of an intro to all this wonderful panel I've got here, which everyone here is at the forefront of have been directly involved in the adoption, implementation, and development of advanced manufacturing altogether. We also are going to be joined by Tony Ho from CAD Space, from purely on a SolidWorks perspective, and a lot of clients dealing with advanced manufacturing there. He'll obviously join us as he comes along. Cool. So I will start now. I'll give an official welcome to the panelists and to everyone here, a bit of an introduction to this event today, and why we're here, why this is a very important topic, and why now more than ever it's important to truly understand advanced manufacturing and how to adopt it and who's done it before. So my name is Victor Vicario. I run Arc Hardware Incubator based in Fortitude Valley. And I started primarily working with a lot of startups, developing new technologies and progressing through their development in the early stages to pre-production. Throughout the years, we've seen more and more companies graduate and actually start manufacturing their products in small quantities. And for early stage companies, we would see a big barrier to development for that low volume production. We also work a lot with industry, and we've initially been helping them out, engaging with brand new technologies being developed by startups. And over time, we've been assisting them to get educated on existing new technologies, such as advanced manufacturing, that can address some really short-term inefficiencies or add productivity benefits to their business. So we've been working with a lot of also service providers, such as the panelists that we have here today and their companies. And the point of this event is really to showcase some practical examples of how advanced manufacturing is adopted in the real world, and what are the practical examples and benefits of it. Because we've been hearing the terminology advanced manufacturing for so long that companies should adopt it. What that means, it's really hard to quantify for individuals. I know that of crossing individuals as well, crossing over the definitions of advanced manufacturing technologies and advanced manufacturing as a process. And what I mean by that is a lot of technologies such as 3D printing, robotics, CNC, CAD and 3D modeling would constitute AI, vision, advanced manufacturing technologies, but they're not good enough to bring that economic value unless they're properly integrated within an environment, either together and with an existing system. We've had the opportunity over the past few months, working with companies, working with government to also leverage ARC to bring a lot of this equipment and make it available for companies to interact with, so they can actually simulate the environment in which they might use it, simulate how they might interact with it. And we've been trialing these open day sessions for the past couple of weeks, where companies would actually come in, very low barrier to entry. We had some samples prepared, some case studies as information to share with the members of the public and business. And it created a very low-key opportunity for that practical engagement with the machine. So we think that is a really good format. We'd like to see a lot more companies, individuals actually step up in person, run the numbers, really balance the pros and the cons and what best technologies that could be integrated with their systems. And we've tested the environment where they can do that with the technology directly, and that's been very positive. We've had some great supporters and sponsors throughout the past few months. So Queensland government has been quite proactive around the advanced manufacturing kind of area and industry and promotion. And a couple of the machines that we have available within our facility have been there because of thanks to the state government. There's obviously other grants available around the adoption and co-funding of advanced manufacturing technologies, both at state government level with the Made in Queensland scheme, but also on the federal level. And for those of you who have been following, there's been quite a few announcements around advanced manufacturing in general and funding to the point of quite a few $1 billion, 1.3 billion, if I'm not mistaken, on that note. So if one's familiar with the Advanced Manufacturing Modernization Fund that has been rolled out earlier this year, that's another one that will be available coming forward. So today we have quite a few very active panelists in the space. So I'll do a bit of a rundown and introduction. I've given a bit of an overview of ARC, but we also have Stephen from SF Design, who with offices both in Perth and Queensland, and even I think other states. Stephen, correct me if I'm wrong, right? We're expanding quite quickly. And SF Design has an engineering background, has worked a lot with companies developing new technologies and plans, have seen a lot of their clients adopt advanced manufacturing technologies, have become resellers of advanced manufacturing technologies such as Markforged and the 3D printers there. So they'll have a great insight from that perspective with a lot of their clients. We have we have Jason from Haddington Dynamics, who will also share some information about his company. And Haddington is quite a fascinating example because on one side, the Haddington creates these robotic collaborative robots, and you'll see from Jason's background, he's got one there as well. But the company also leverages advanced manufacturing as a process to make those robots. So the robots themselves would then be used by industry to automate certain processes, but also the manufacturing technologies adopted by their company has implemented a few systems in place that make economic, obviously, sense. We have Amanda from Freelance Robotics. Amanda. So here we have a company who works a lot to help develop custom systems for their clients in the automation space. Quite varied, and I'm looking forward to hearing some great examples of projects which have been adopting advanced manufacturing tech there. Ben from Decisive Technology. So Ben works closely with Haddington as well. In fact, Decisive manufactures the robotic arms, the Haddington's robotic arms in Toowoomba. So here in Queensland, so we have another examples of local manufacturing of advanced manufacturing technologies adopting advanced manufacturing as a process to do so. But Decisive Technology also takes their know-how and knowledge to work with a lot of companies to implement the technology and develop custom systems there. So we have Yuxi from Lyra as well. Lyra is developing a brand new technology on their own, integrating both the mechanical systems of this automated picking robot that they're initially using in the agricultural sector, but can be applied in many warehouse and logistics environments. So they were developing both the technology and the smarts, the AI, and the person behind it. And the model they're applying is it's a robot as a service. So it's actually being a system that can be deployed when needed within an environment, can learn very quickly, and can bring those economic benefits. So again, an example of a company both adopting the technologies to create their new device and product, but their product is ultimately an advanced manufacturing, can create this advanced manufacturing process that brings this economic benefit to their clients. And lastly, we had Tony, who has joined us from CAD Space, and he will give his overview and his experience with a lot of his clients. Now, CAD Space is a reseller of SolidWorks, which is a CAD software platform, and he works with a lot of companies digitizing their process, creating digital twins, and ultimately interacting and engaging with advanced manufacturing technologies there. So this is the full panel. At the end, we'll have a Q&A session for everyone or anyone interested in who has some specific questions. Please do add them in the Q&A, a little chat box, and I'll ask the panelists when we're done. All right. So, Stephen, I will, let's see, make you host once again.
Okay.
And you'll be able to share your screen, and we'd love to hear some examples that you've experienced in this space.
Fantastic, thank you. So firstly, just to check, can you see the right screen there?
Yes, I can see it here.
Fantastic. So Victor, thanks very much for the introduction. So as Victor's mentioned, my name's Steve. I'm the Business Development Manager for SF Design. We have a number of different sort of strings to our bow. As Victor's mentioned, we're an engineering consultancy, and we got involved in additive manufacturing through our own engineering projects in-house. And that led fairly kind of obviously and neatly onto actually supplying 3D printing and additive manufacturing and design for additive manufacturing resources to our customers and additional customers beyond. I'm based here in Queensland. We've also got representatives in South Australia, and as Victor's mentioned, we are looking to expand as much as we possibly can. And so what I wanted to do is I'll be pretty brief to keep us on time. But really what I want to talk about is the concept of a functional 3D printed part. So there's probably a lot of people on this webinar that have got experience in 3D printing, and they've worked in the likes of ABS and PLA and found the lack of strength and the lack of accuracy a potential problem. So what we're looking to try and solve with Markforged is being able to create that trifecta of a part that's not only strong, tough, and precise and accurate, but is also quick enough to print and is also low enough cost to be able to actually make a realistic difference. So what I wanted to do is start to think about some specific real world examples. So currently what are the possibilities with 3D printing right now, and where are the successes that we're seeing some of our customers? So I'm just gonna talk about a few of these. One area that we talk about, and Jason will no doubt add to this in terms of the robotics side of things, but end-of-arm tooling is a really important area for the use of Markforged and generally around additive manufacturing. So the ability to print sort of very complex shapes, not only for allowing for better cost, but also for more comfortable grip for ergonomic designs. One of my mantras is very much the case that complexity is free when it comes to 3D manufacturing and 3D printing. It doesn't matter how complex the part is. It doesn't necessarily add to the price, add to the cost, as you would see with standard subtractive manufacturing or traditional machining. Have I got my presentation notes on the wrong side? Is that better? There we go. Sorry about that, guys. So this is what we're going to talk about. Talk about end-of-arm tooling. So, first example is an application from an automotive customer. So they use these horizontal transport cells to shuttle large castings backwards and forwards out of a machining center. And there are 4 end effectors on the cell which grip onto the casting. And it was a really bad actor for this particular plant due to the amount of breakages that they were having. And the tool was it's a 3-piece assembly, and it was machined by a third-party vendor. So they're having to get these externally produced. And generally speaking, the lead time was anything up to 16 weeks. And what that meant was that they were having to keep a really high inventory in stock on shelf because they just couldn't afford the downtime and having to wait. So they approached SF Design and asked if we were able to help with the use of additive manufacturing. So what we did was we created what we call a hybrid part. So you can see on the left that there's a fiber reinforced arm that was laid out. On the right hand side, we created a H13 tool steel metal printed part to accompany. And what we were left with was what we call a hybrid part of both composite and metal structures, all completely 3D printed using Markforged solutions. And what it meant was we could optimize both the production and the method of the application. So the results were pretty amazing. You know, the weight reduction had actually a twofold benefit. It turned a two-man job into a one-man job, and it also reduced the cycle time as well. Not only that, the inventory was able to be reduced because the part was basically now part of their digital inventory rather than needing to keep a lot of in-house stock available. So that massively reduced their lead times. It was a really, really nasty environment, as you can see from the photo. There's a lot of coolant and there's chips everywhere. And nowadays, the longevity of the part is far, far longer in this particular application. So another particular area that Markforged are getting involved in is CMM fixtures. So JJ Churchill in Australia, they make very complex aerospace power generation parts. So they're leveraging composite technology to print custom CMM fixtures for turbine blade inspections. So strength's not necessarily a requirement here, but by using continuous carbon fiber from the Markforged printers, it creates tremendous stability. So the added benefit of using Onyx over a machine part is a little non-marring surface as well. So the CMM fixture is far advantageous as a 3D printed part. And again, as you'd expect when comparing this to traditional manufacturing, you know, the results are very, very impressive. You know, you are looking at a 90% cost reduction, which sounds like a lot, but depending on the application, you know, it is absolutely possible. So another area is rapid prototyping, and specifically in mold tools. So in Teledesign, they were contacted by the client to help improve on-site groundwater quality monitoring. And the client wanted to replace a manual process, which involved collecting samples in person, with an automated system, so they could do it off-site through IoT technology. They only needed 8 initial prototypes of this particular mold. So given the small production quantity and high production cost, Teledesign used their Markforged 3D printer to create a mold for a polyurethane part that was critical to the system. So the mold's printed in 2 halves, and this particular part was only took 60 hours to print, rather than 3 weeks to arrive from an external outsourced area that they would normally have to go through. And it's also far, far cheaper. You know, you're talking around about $400 rather than sort of 3 times that they would normally expect to have. So what Teledesign were able to do is massively reduce their lead times and massively reduce their costs by utilizing Markforged additive manufacturing solutions for this rapid prototyping within the mold tool environment. The final one I want to pick on is press brake tooling. It's not necessarily something that you would necessarily think about when it comes to additive manufacturing. You know, you're thinking, come on, how is a 3D printed part going to be strong enough to be able to help in press brake tooling? But Centerline Engineering, they're a small job shop over in Perth, near our head office. And they came across a job that required a short run. And instead of working with a traditional sort of tool and die shop to get the press brake tooling made, they came to us to see if there was something that we could do. And no, it turns out that there was. And they were actually able to utilize a specific feature of the Markforged system called print to pause to insert these metal plates that provided support in the really high stress areas. So the results were absolutely fantastic. You know, they were able to run all the 14 gauge steel using all of this tooling. And again, you know, the cost reductions and the lead times that we see are absolutely fantastic. So what I would say is, think about the different areas within your businesses that you think additive manufacturing and 3D printing may well become more and more, is becoming more and more prevalent. The sky is very much the limit. My mantra is, it depends on the application, and we are more than happy at SF Design to look at any application that we can get our hands on to see what we can do. So with that, hopefully I'm pretty much in time. So I think we're going to leave the questions to the end, but if you do have any questions, I'm happy to answer them in the chat. So that's me from SF Design. I'll now hand over controls to Jason, and he'll be able to talk to you about the Haddington Dynamics Dexter. So
thank you, Stephen.
There you go, Jason.
Thanks, Stephen. That was great, and it's great to hear from one of our partners, SF Design, and Stephen's an old mate of mine as well. And we're joined today by a couple of my partners. We've got Ben here, who represents Decisive, and he runs one of our MICROFACTORYs, and I've got Yuxi, a good mate of mine as well, and been involved a little bit. So it's a great little family gathering here. So without much further ado, I'll go into our little presentation, and what I want to do is talk about the story of Haddington a little bit and where we're going. I'm actually going to leave the technical part of the discussion to Ben, because Ben builds our robots here in Australia, and it's a pretty exciting project that we have going on there. So let me see if I just share this. Okay, so everyone can see, I'm assuming, what I'm doing now. So basically, here we go. I've got the screen here. Okay, just a little bit about Haddington Dynamics and where we started. So yeah, we're a startup, and from my perspective, I actually first saw Haddington in a case study when I was selling MarkForged printers, and contacted them. The reason I was involved, obviously, MarkForged is a bit of a theme here again today, and the guys in Vegas were being showcased by MarkForged because they had managed to set up what I was trying to promote here in Australia, is the idea of 3D print farms. We often hear that 3D printing isn't really fit for process, for manufacturing, because it's too slow. Well, as a salesman, as a salesman of 3D printers, my answer to that was, well, you can double the speed by buying 2. You can quadruple the speed by buying 4. So suddenly, once you start to get to a critical mass, and we have like 20 MarkForged 3D printers and a couple of other little ones as well in our head office in Vegas, and I think Ben's got about 3 so far, and probably another couple. The ability to be able to flexibly design the stuff was pretty important, and this is what Kent Gilson really came across when he was looking at ways of manufacturing it without being tied to big industrial processes. We all know, if you're going to go down the route of plastic injection molding, huge overhead costs and tooling and minimum order quantities. We were able to bypass that. And it was a journey. They started out with the PLA printers, with laser cutters and all that sort of stuff, till they actually ended up with a product that they were ready to launch as a kit on Kickstarter in 2015. Previous to that, Kent has been, a bit of a serial entrepreneur and has started a couple of companies previously, worked very, very closely with FPGA boards. The successful Kickstarter was launched. We dispatched our first kits across the planet. A couple of them did land in Australia, but largely it was in the States. As a consequence of that, Hackaday Prize, we won. And then, we started, I joined in 2019 and helped launch the Dexter HDI in Singapore at an event there. This time last year, sort of. Been a strange year. And then we set up a couple of resellers, but really the big leap forward was meeting, doing the deal with Decisive. So Decisive Technologies set up the first manufacturing microfactory outside of the States, in Toowoomba. And, obviously Ben's going to go into that a little bit more. But that's been a real progress. And the guys, Ben and his father, Ross, have been incredible advocates of technology, and also now doing their own R&D here in Australia. But more recently, we've finally graduated. I'm going to talk about that a little bit more. In the last month, we've officially been purchased, and we're no longer a small startup anymore. We've been purchased by Ocado Technology, and I'll talk a little bit about that in a minute. So over the years, we started out with a product, as you do, which is not necessarily fit for purpose. I mean, everyone here knows what a minimum viable product is, and that's certainly what Haddington started with. However, there were some pretty unique sort of little secrets, herbs and spices in the middle of it. I'm going to let Ben talk more about the technology, but I will make mention that we have a pretty unique optical encoder, which allows us to pretty much, to say it bluntly, gives us a sense of touch, to be able to use reverse kinematics to feel things. And like I said, I'm going to let Ben go into that again. But the some product is we had an MVP with a pretty unique bit of technology, and really that's what you have to do to stand out in the pretty much getting crowded space of robotics right now. You need that secret spice, and that's what we have. So yeah, we've done some pretty impressive work. Obviously, Markforged and Autodesk have been fantastic sort of help. But more recently, we've been dealing with Intel, and NASA has been probably one of our original cheerleaders on the back of work that our founder did with them many, many years ago, doing drone inspections and doing them by touch, because we have that sense of touch and feel, and we can determine a 5-micron deviation, which would be very, very hard to determine with a vision system. So certainly, NASA have taken our technology a little bit further. But yes, the microfactory structure, that is really probably one of the real innovative elements of the offering. And like I said, Ben's going to talk about that in a little bit of time. But really what we determined was, instead of going down the traditional route of manufacturing, which is to set up a big factory, do some tooling on CNC machines for plastic injection molding, which can cost thousands and thousands to keep that stock in. And certainly the other challenge around that sort of setup is that, once you've committed to a tooling run or whatever, you're pretty much committed to those parts. It's very, very difficult to reiterate a part once you've got 1,000 in stock. So what we determined was a microfactory, or 3D print farms and microfactories was certainly the way forward for us. And we've now obviously decisive the first in the world, really, and we've now got about 3 or 4 others opening up in the States. And the advantages it gives us is many. So one of the advantages is certainly that we're able to build in regional areas. So, for example, Ocado, that are our new master, have given us a challenge to build a robot for their purposes. But when they deploy those robots, eventually, the Australian ones are going to be probably built by Ben and his team in Toowoomba. So we get that local advantage, and obviously less import duties and all those sorts of things. But the other upside is we automatically end up with a service system. Normally, as the case, you set up a big old middle factory, and then you're going to set up all these service units around the world. We do away with that, because we certainly go to the factories which double up as service centers. So, for example, Ben and his team are already looking after this region. We've got machines in Singapore, we've got machines all over the country now, and starting to build up as we wake up out of this COVID sort of coma. But yeah, so the big news for us is we were bought out by Ocado. Now, anyone doesn't know Ocado are one of probably the leading technology firms in the UK, certainly at the moment. And they have pioneered and developed the systems of grocery delivery en masse. their systems rival Amazon in terms of their pick and place systems, in terms of speed and the speed of the stack that they're being able to build. But they've become somewhat ubiquitous in the UK after winning the bid to deliver all of Marks and Spencer's stuff. They've done a deal with Coles in Australia, and they've also done deals with Kroger in the States and many others. Tata is currently valued at $22 billion in terms of its net worth, and they are on the acquisition trail. Well, they have been until this year. They bought us and another company called Kindred with a view to improving the speed and efficiency of their pick and place systems. I can't really say much more than that because of NDAs, but certainly that is the idea. However, we will be running concurrently their project and also our MICROFACTORY project for outreach. And we are entering a new phase. So I should sort of really explain to people that don't know that our robot is referred to, our Dexter robot is referred to as a COBOT, which means collaborative robot. And it is a real sort of trend that has happened in the last probably 10 years. Universal Robots really pioneered this space. And what a cobot is essentially a robot that can interact with humans. Traditionally, the big robots that you'd see in car manufacturing facilities have to be geo-fenced. And obviously for safety purposes, humans cannot go anywhere near them by rule. The difference is with a cobot is that the humans can work concurrently with a robot. The way that Dexter is configured is if Dexter is activated and running and it bumps into me, it would immediately stop and go into its home position. That's what it's designed to do. And that does it natively. And that's what all cobots essentially are designed to do, to work with a person. And at the moment, cobots represent, I think, 5% of worldwide robots, but they're the fastest growing segment, where we're looking at, $4,000 million worth of robots being forecast as a compound aggregate over the next 4 years or so. So we're looking at huge growth in the space. And so why would you want to use a robot like this? Well, we have a design coming up, and this is an early stage. The next sort of push we'll be doing is what we call our DEX cell. It's a work cell robot. And what could you do with something like this? Well, basically, we have a base. What we're trying to do is as close to as plug and play robot as possible. Most of you know about robots, know that there's a lot of scopes of works. We have to program end of arm options and all sorts of bits and pieces to actually make a robot fit for some sort of manufacturing process or any of the dull, dangerous and dirty jobs that robots are sort of being scheduled to do. What we've designed here is what we call the DEX cell, which is a mounted robot. It won't actually be on the system that you have here. We're like an optical breadboard, but we are able to incorporate tool change systems. So potentially these robots could be used for, by jewelers where they want to do some, polishing and deburring after they've done castings, or precise manipulation of certain assemblies, small assemblies where we maybe need to do a thin line of epoxy resin before something is placed together, or accurately place screws with specific torques, and the sort of things that robots are really good at and humans necessarily aren't. Repetitive tasks tend to give people repetitive strain injuries, and this is the area we need to sort of move in. Another really interesting sort of development is teleoperation, and teleoperation is obviously operation of a robot at a distance. More recently, we worked with a team in Nevada, actually, I think it was in the desert somewhere. This team, Avatar Medic, are working towards the Avatar X Prize, which is a $10 million prize to create technology for Mars, for the Mars mission. And this particular team has decided to devote their energies to creating an autonomous robot which can perform basic sort of medical procedures. and also do it at distance. So we were able to successfully work with a 4G network in the middle of the desert and teleoperate one of our robots. It's one of the operations that we did. You know, going forward, we're looking at, for example, putting microfactories into shipping containers, where we'll be able to deploy these microfactories anywhere in the world to be able to do assemblies, to be able to create parts, to you know, do a bunch of different things. I've personally had extensive chats with military around this, who are very, very particularly interested. But you know, there's many options of what we could necessarily do about operating a 3D print farm, automated with a robot. Essentially, our vision is in the next few years to use our own robots to do more of our assembly, and that's something that, you know, we are sort of working on with some sort of projects. But yeah, that's sort of about it for me. I want to keep this short as we're sort of running for time. I'm going to pass to the next guy, but I'm sure we'll have some questions at the end of it. So I think at this stage I stop sharing.
Yeah, so we'll pass it to
who do I pass to next? Who's next? Victor?
Amanda's next.
Amanda, okay.
So if you can...
Hey, yes, it's me, I think. Thank you, Victor, for organising today. And I'd like to say on behalf of Freelance Robotics that we're very excited to be involved. My name is Dr. Amanda White, and I'm working with Freelance Robotics, which is an established engineering firm, and we're based currently in Capalaba, which is just on the outskirts of Brisbane, and soon we'll be heading out to the Redlands Business Park in early 2021. We are actually a services-based company, which is slightly different to a number of other businesses that you'll find inside of our area. But we do have some products underway that I'm going to talk to you about. Before I get too far into it, I've just realized that I've got an audio track behind me. Is that just too loud for you, Victor? How are we going? It's okay?
From my side, it's fine.
Okay, all right. Let me know if it becomes irritating for anybody. Okay, so our work brings together industrial and R&D knowledge, and we specialize in the development of prototypes from the ideas stage through to market-ready products. So those minimum viable products you've been talking about, we're the people that are contacted to transform them into something that can be commercialized and rolled out into whatever it might be that the person who is engaged with us is looking to develop industry-wise. We specialize in custom hardware, custom software, and custom machinery as well. As projects are actually based on our customers' need, Freelance Robotics has a variety of projects underway, from a coffee-serving barista robot that I'm sure we're all looking forward to releasing out into the marketplace, through to construction drones that are operating in roofing. We'll take a look at that as a case study shortly. And as well as we're doing agricultural robots that can check plant needs whilst eradicating pests and weeds down the plough line. So we offer an established, highly skilled team of mechatronic engineers, and their engineering skill set covers robotics and automation. Clearly, this is key to the world of industrial automation, but we're very proficient in the world of mechanics, information technology, control and filtering, electronics, as well as artificial intelligence. If you're looking for a robotic prototype, we offer a range of wheeled robots, track robots, robotic arms as well. I'm going to discuss with you shortly the partnerships we have with established brands that we rep for in addition to organising our own equipment. We have unmanned aerial vehicles, marine robots, bipeds, quadrupeds, hexapods, and vehicle automation. There's a range of products that can be developed from the skills that we have on tap. And so we really encourage customers, if they have an idea that they think they would like to bring forward, and it might not be to commercialization, maybe they're just looking to refit or change the way in which they're currently working inside of their factory, then it's really worth contacting us for a consultation. Our first consultation is always no obligation, and it's also no cost as well. So you can have a senior engineer come on site to you We work clearly in the local industry here in Southeast Queensland, but we also have operational jobs interstate and also internationally. If you are working interstate or internationally, then that meeting would probably be best organised through a Zoom meeting rather than in person, just because, you know, COVID has certainly restricted what we can do. Our in-house projects that we've been working on come from this idea that, you know, as we've been working through the service development for other customers, we have retained intellectual property just through the development stage. It is our general decision when we're going into contracting that we do not hold any customer IP and we're not paid in customer IP. So over the course of the last 10 years, we've developed an intellectual property profile slowly, incrementally, and we now have coming to market what we will firstly call France, which is the Freelance Robotics Autonomous Navigation System. This is an extremely robust autonomous navigation system. It operates across multiple platforms, and it is also agnostic. Currently it's only 2D, so it operates on wheeled robots, track robots, but in the coming year we're moving into 3D, so that will also include aerial drones and submersible drones as well. It operates to within 2 centimeters accuracy, and we currently have 500-meter irrigator sets operating singleton within that degree of accuracy on a daily basis. So we're feeling very confident in this product. We also have formation customers. This is Freelance Robotics Advanced Manufacturing Elements. The idea is that the majority of people who are working in factories, generally they're running a small business. It's under 50 employees. And the reality is that transforming an entire factory is just beyond the budgetary capacity of most small businesses. So what we've decided to put together is a modular system where the customer comes in, they make a clear explanation of where they would like to upgrade their factory. The first step is always to have a look at the utility of whether this is actually going to benefit their factory. And we're also looking at retaining and also upskilling the staff so that we don't lose any of our staff members. Actually, we're increasing their technical ability by having robots as tools. So framework comes in agnostic, which means it's not system dependent. It doesn't matter what kind of systems you're operating from. Maybe it's ABB, maybe it's Omron. It could be a range of different technology brands. Our system is designed to mesh with whatever it is that you're currently operating. And we put together a plan for your workplace, which is an incremental stepping stone plan. So you don't have to think about a full turnkey solution unless that's what you want to do. Often people are looking to develop the things that are going to make the most benefit to the bottom line and also increase the safety of their workplace sooner. We're finding, and we'll have a look at this in a moment, at welding robots being a very hot commodity at the moment. Clearly, with the amount of risk that's associated with welding, it is fumes, it is visually very dangerous, and also the burn risk that comes with welding, in addition to repetitive strain injury. The reality is that we need to treat our workers better, and we need to come up with ways to automate jobs that are actually very repetitive anyway. We're taking the creative elements of what your staff are currently doing, and we're transferring that to a new type of tool, which is the collaborative robot. Now, let me talk to you a bit about our industrial robotics division. You can see here on the screen, we have an overview of what our new division is really focused on. It's really focused on getting your business to reduce risk and increase its productivity and also its financial value for you as a customer. So, you know, smart transformation is innovating our local manufacturers. Our first case example that we're going to see here is a local business to us. It's located in Thornlands called Bevco. You've probably had an Orchie drink at some point in the course of the last few decades. The reality is that they needed to upgrade their equipment. Here we have the Orchie factory. You can see a pick and place robot operating. You know, as we find out that the equipment was really fully functional, what you need to do is think about how we can not just upgrade it initially, but then we think about over time, recipes change, sizing of equipment changes, palletizing changes. we're more than happy to come on board and not just do an immediate job and walk away. Our customer service is quite exceptional. We're very interested in forming a partnership with businesses. So Bevco has been an ongoing customer with Freelance Robotics now for the past 5 years. You can see that we are operating a pick and place robot here and also a conveyor belt system. Now, when we're working in food production, there's also the utility for what we call soft robotics. You would think of that as a very soft end effector for your robot arm so that you can move about delicate objects such as baked goods. This actually is very effective for not only moving through the volume of work that comes when we're talking food and beverage processing, but it's extremely hygienic, and additionally it reduces the workplace injury from heat access to the ovens or whatever it might look like where that food processing is taking place. We do work a lot with fruit providers, and in fact we also work with Toffee Land. If you go to Woolworths or Coles, you'll find that there's still toffee apples available, and they were operating manually all of the toffee apples production for a national delivery. It was incredible and also very high risk because toffee is not an easy product to work with. So when it came down to working with food and beverage, we've actually found a lot of very successful outcomes. Now, our engineering and integrated team, we build custom machinery. So we do also do custom end effectors depending upon what sort of production is underway. We work with a range of different providers. As I said just briefly before, when it comes down to it, if there's something that's really a high value item, and we know that when it comes to off the shelf purchasing, this is a more cost effective way to go about things. We decided to build relationships with existing technology companies. So for instance, in the industrial space, we work with ABB, Omron, Yaskawa, as well as KUKA. And the reality is that we're going in and integrating their equipment into factories, or alternatively, we're producing bespoke solutions to what the customer is looking for, because it's not always easy to get an off-the-shelf product when what you're doing is not a standard type of factory outcome. So what we're delivering in advanced manufacturing is really just at the bottom line to assist the customer to get there in full and on time and improve the consistency. And by doing that, the product is improved. And if you are looking at something like metal fabrication or plastics fabrication, what we're finding is that the consistency improvements are leading to better warranties. And as you have a better warranty, what that means is you get better market positioning. So we have companies that are very established inside of Australia. Our welding robots are working at the moment in Page Stainless. We're putting together a very exciting new project for PTE Hydraulics, where we're introducing a welding system as well as a deburring system. And we're also working with Hallmark trailers, so that we can produce for them a new way of welding large haulage trailers, which is really, I think, a huge advantage to what we currently have on the market. Now, what we're finding out from talking to our customers is that, as I said before, warranties are improving. As warranties improve, people get better industrial positioning, not just in the local market, because the Australian market is quite small. As lead adopters, they're finding that they can now move more successfully into international marketplaces. Depending upon what the customer is looking for in the next 5 to 10 years for their return on investment, the idea of expanding your customer base and moving into international markets where there are far more customers who are looking for a far more diverse profile of product, it becomes very exciting when you sit down and you do your business plan for the next few years and realize that the capacity of what your company can do as a small business has really exceeded what was possible before we put inside the industrial automation equipment. We're finding that we're upgrading facilities, we're upgrading business plans, and we're also upgrading, as I said before, the staff members. Now, I'm very proud of the fact that we offer a service with the Industrial Robotics Division, which is unique inside of our ecosystem as robotics providers. And that is actually an organizational and industrial psychology service. So I said I was a doctor, Dr. Amanda White, and in fact, I'm a psychologist, and I put together a program when we go inside businesses to upgrade their machinery. it's very clear that for projects to be their most successful, we need to make sure that we have upskilled, well-trained and well-supported operators of that machinery. So it's really hand-in-hand business. When we go through the technical aspects of a rollout, we're also going through a training protocol where we sit down and we spend some time with the operators, talk about what their needs are in terms of training, put together a very clear learning profile per trainee. And then there's the idea of what happens after the training. Well, we want to make sure we don't have a key man scenario where all of that operator knowledge is kind of held inside of maybe a small group of people. So the other thing that we're looking at in terms of supporting businesses is getting in-house training up and running. If you're looking to develop ISO 9000 or another ISO standard for your factory, the reality is that having a very effective workplace training system is going to make a massive difference for you. So we do offer workplace assessment training and support services after the technical rollout. And that's about it for us. Thank you so much for listening to me for the last 15 minutes. It's been a real pleasure. Freelance Robotics, you can contact us at admin@freelancerobotics.com.au, or you can pick up the phone and give us a call, 1300 4ROBOT. We'd look forward to talking to you. Thank you.
Thank you, Amanda, very much for that. And if you don't mind making Ben the admin.
Hey Ben, here we are. Yes.
There you go. Ben, you should be able to share your screen and give a bit of an overview of what you've been working on and some customer experiences and that you can share.
Yep.
Thank you.
So have you got that up? All good? All right. So hi everyone, and firstly thanks to Victor and the team at Arc Hardware for organising the event. I appreciate the opportunity to speak and hope to provide some useful information to everybody. Well done to all the speakers so far, and thanks to all who have taken time to tune in online and be here with us today. My name is Ben Lehman and my background is in mechanical engineering and control systems integration and economics. I'm the director for Decisive Technologies, which manufactures the Dexter HDI, as Jason's told you about, under license from Huntington Dynamics. And you heard Jason speak earlier about the Huntington Dynamics story, and hopefully I can add to that with a new perspective and a bit more technical detail. So I'm going to be talking to you firstly about my definition of advanced manufacturing, which Victor has covered briefly as well. Where Decisive Technology sits within my definition of advanced manufacturing, why I'm excited about the technology behind the Dexter HDI, the future I see for Decisive Technologies, Huntington Dynamics and the robotics industry in general, a brief guide to specifying project requirements, evaluating costs and return on investment for robotic automation projects, and finish with a case study that hopefully embodies some of what I'll cover throughout the presentation. So I've got two definitions of advanced manufacturing, which are very similar to what Victor has already described. One definition is manufacturing advanced products, and the other is making products using advanced manufacturing processes. I don't believe that advanced manufacturing is new or revolutionary. I think that there's thousands of businesses out there today already implementing advanced manufacturing. However, I do believe if you are a manufacturer and you're not manufacturing advanced products, nor making products using advanced manufacturing processes, then you'll struggle to be relevant and competitive in today's economic climate. Decisive Technologies, I believe, is manufacturing an advanced product. I think there's many improvements we can make to our assembly processes using advanced manufacturing processes, including robotics and industrial automation solutions. And we're going to aim to implement these solutions as we scale. What excites me most about the Dexter HDI is its control system, which is what Jason also touched on earlier. The control system, it uses analog signals from low-cost LEDs photodiodes, and uses 3D printed code disks and samples the feedback at 200 kilohertz using an onboard parallel processor. The code disks and optical hardware are mounted at the point of rotation, which means all the backlash in the system is accounted for within the control loop. And it means that the robot has load adaptive repeatability. So you can change the load and inertia of the gripper in real time without losing repeatability. And Jason mentioned, the touch sensitivity, which is a similar thing. So combining that with a load adaptive gripper, the robot could pick up delicate, lightweight objects or heavy objects and change tools all in the same process without losing repeatability. And the significance for that, for me, is that is one of the challenging parts of robotics solved economically and using a manufacturing process that can be quickly repeated anywhere in the world without sacrificing quality. And we're only just at the beginning. There's numerous improvements in the pipeline for the Dexter HDI right now, including achieving high quality ingress protection to protect all of the onboard electronics. And we're going to aim for IP54 or higher. We want to increase the payload capacity and gripping torque. We can limit electrical interference and optimize our electrical design. We want to make our programming as intuitive as possible and develop our learning resources, and then improve the ease of interface and integration with surrounding equipment, which is essential to any robotic solution. And those are all problems I believe that can be solved. It's just going to be a matter of time and resources. But what's important is that we have access to a fundamental base technology that I would consider advanced, and we're able to offer that technology cost competitively, even at low volumes. We've got significant scope, knowledge, and ability to improve production efficiencies using our advanced manufacturing processes. And in collaboration with Haddington and their partners around the world, I'm confident that we're going to be able to reduce the costs and spread the knowledge of robotic automation to help enable economically viable robotic solutions for small, medium, and global enterprises. So that's a brief description of the opportunities I see for us at Decisive, but I also want to talk about an approach to evaluating the implementation of an advanced manufacturing process, that being a robotic and industrial automation project, and probably in the cobot space more so than some of the larger welding equipment that Amanda has been talking about. But maybe some of the principles still cross over. An advanced manufacturing process, I know it's not necessarily limited to robotic and industrial automation, but this will be my focus. So I think the first step is to identify and define the opportunity for automation, which involves specifying the requirements for your application, requirements being what you need the application to achieve. So, what's the task, what's the cycle time and duty cycle, the acceptable reject rate, what's the payload or the weight of the object you need to manipulate, how precise do you need to be, do you need to have precision down to centimeters, millimeters, or microns, are you interfacing with human operators, which this has implications for machine guarding safety and functional safety. For example, do you need to apply e-stops or soft limits for forces, torques, and speeds? Do you need a human machine interface, or do you need to integrate with surrounding plant equipment? And then also consider, what constraints do you have? You have space constraints, or do you already have electrical cabinets installed with fixed spare capacity? Are you limited to a specific communications protocol? And what existing services do you have access to, whether it be a pneumatic air supply or a 24-volt DC power supply? And do you have any existing documentation? Finally, what's the environment? Are you inside or outside? Are you in an educational environment or in a laboratory? Is it a light industrial environment with controlled temperature and humidity, or is it dust-free, or a heavy industrial environment with wet and dusty conditions. All of these variables impact the conceptual design, robotic selection, or whether a robot is even the right tool for the job. And they also significantly impact the scope and costs of the project. If there's no existing design, then the next stage of the project is the conceptual design, which will generally take a small upfront cost to develop, and will focus on how you want to achieve your specified requirements. So this is going to include a conceptual or modified plant layout, and you need to take into account the location of your equipment, services, and raw materials. You need to evaluate the suitability of a robotic solution and the robot selection if required. And as I said before, it could be that a custom automation solution might be more suitable for your application. The design needs to propose methods for object detection, positioning, grasping, and placement, particularly a robotic project. And this may include whether or not a vision system is required, and evaluating whether a vision system is suitable for the application. I think Yuxi will be able to elaborate a lot more on vision systems. And finally, the design should consider the process flow and propose methods for product in-feed and out-feed, and how you're going to handle rejects. You might need, a vibratory feeder or an indexing conveyor, or other standard industrial machinery. So this conceptual design will form the basis for determining the costs and risks of the project, which will need to be evaluated at a high level. And generally, you're going to have a budget estimate at this stage. The four major design risks I think are important to think about and mitigate for design, safety, business, and risk of failure. So by design risk, I mean, is it proven or adapted from a proven design, or has a supplier implemented similar solutions for other clients? For safety, are you introducing the potential to cause human injury, and can the safety risks be managed? And this will often be in the form of a formal risk assessment and functional safety assessment. In terms of business risk, you have lead time and downtime risk. Are you on a tight schedule, or are you going to lose revenue if the project is delayed? And how much are you going to lose if the automation solution breaks down? Can you build in redundancy, or can you afford to build in redundancy? Finally, you have to consider the risk of failure, and hopefully this is going to be a rare occurrence. However, it should always be considered, I think, as a worst case scenario. Can you afford the project to fail? Are you need to take out a loan for it? And it's really about evaluating the severity of the failure and whether or not you can live with the consequences. And I think if you can, then it makes you a lot more confident in your decision to move forward with the project. So we need to always evaluate the risks and costs against the benefits, and mostly these will be derived from either increased productivity, increased quality and reliability, or increased safety. And Amanda had some great examples of applications where they've achieved that for their clients. So, you could be helping your clients do more with existing human resources, or you could complete tasks faster. You might be enabled to operate longer hours or reduce downtime. You could reduce stress and pressure on human operators, or reduce the repetitiveness for your labour force and provide them with more interesting and varied work. Or you could protect them from hazardous environments, and obviously eliminate the repeatability of the work. Or could become more repeatable and consistent. But whatever the benefits you identify, you need to apply a method for quantifying those benefits against the upfront and ongoing costs, including costs of operation, maintenance, including labour and materials, your downtime, equipment life cycle, and capital depreciation and replacement costs. And if you decide to proceed, then the project will move to detailed costing, followed by detailed design and implementation. I've put together a generic list of cost items for any typical automation project, and I'm not going to go ahead and list them all out because I could probably speak for 5 minutes on each of them. But as you can see, they all add up. So it's crucial in the conceptual design phase that the design is optimized for a cost-effective solution. And the important thing to remember, particularly for a robotic solution, is that the robot's only one part of the puzzle and can rarely provide value as a standalone item. So that's a brief summary of my approach to robotic automation projects, and I'll try and finish on a case study. I want to show you a project that we worked on that involved the principles of robotic automation that I've mentioned. At its core, the application was a robotic sorting application. So we were presented with circular objects that were randomly distributed in a grid pattern, and they needed to be located and sorted by size. We used a vision system to detect the objects, which involved lighting the objects from above through a transparent surface and taking an image from below. And you can see in the image that the discs are sitting on a tray, that it's actually a perspex tray, so we could take the image from below. And we used, what that did was remove color as a variable, and it gave us a good contrast to size the objects. We used an 18 megapixel camera so that we could size objects within a 0.3 millimeter tolerance over a 600 by 400 millimeter surface. And the image was analyzed using OpenCV, and the size and XY coordinates were sent as an array to an industrial controller. And then we programmed a sorting algorithm and interfaced a suction gripper with the industrial controller. And then the robot and the controller shook hands with each other to achieve a common sequence to sort the objects by size. And I'll show a video, hopefully it works, that's the outcome of our feasibility study on this project. So, I might try, I do have it preloaded. Sorry, I'll try sharing a different screen quickly.
No problem. We've actually been running quite smoothly since the beginning, so.
Okay.
This is more the exception than the norm. So well, it should be the norm more the exception, but it's all good. And I'll take it this opportunity to remind. I've got a few questions that have been posted previously through by email messaging. Anyone who's listening to these sessions right now and has some immediate questions, please add them to that chat in Q&A. All right.
Okay, so thanks, Victor, for filling that little gap in. So here's the video, and I hope the sound comes through. So I don't think the sound's coming through, but yeah, basically all the discs were in a random order, and it was just sorting it by size. So I think that the next step for that project was to optimize the speed of the application, and but that was at least the outcome of our feasibility study, which we were able to video and get a good demonstration of the robot. So thanks everyone for listening, and I'll hand back to Victor.
Thank you, Ben. If you don't mind making Yuxi our next host.
Yep.
And you talk about vision, you talk about custom environments and picking and placing, and I think it's here the perfect segue to go into. So I'll let you explain what you do and what Lyra does.
Yeah, thanks. Can you guys see the screen? Cool. Yeah, thanks, Victor, for organizing, and thanks for having me. Yeah, it feels a bit like a bit of a family reunion, as Jason mentioned before. There's a lot of, I think, a lot of capabilities here in Queensland and in Australia, especially coming up in the robotics sector. As was mentioned before, that the robotics space is getting crowded. I disagree. I think we're just at the very beginning of what robotics actually can, provide over the next decade or decades. And I think we're just really at the beginning of what robotics really can bring to the table. It just, ballpark number, there's a $30 billion market for just warehouse automation, right? So that's a huge market. And yes, there might be like 20 players in it, but 30 billion divided by 20 is still a significant large market. That said, Australia, I think, has a lot of things to offer. I'm going to talk briefly about what we do at Lyra, with a bit more of a twist into what I believe manufacturing can do. And as Victor sort of suggested before, we are a robotics company. So Lyra is based in 8 Mile Plains. We're a spin out of the Australian Centre for Robotic Vision, and we create smart robotic systems. But at the core, we're actually creating systems that are smart enough to do advanced manufacturing tasks. But to build these robotic systems, we require advanced manufacturing tasks, right? So this is sort of like a bit the interplay. And I think you see that a lot more happening with a few companies, right? I mean, most of the people that talked today were talking about that, and you see that sort of coming together because it is advanced technologies. So our goal at Lyra is to create robots that work, right? And it sounds simple, but it turns out to be hard. And I've been in academia for a long time trying to make it happen. And I jumped ship last year because I believe we're at a point where that actually makes sense. And what we want to do at Lyra is not just build one robotic system, but build 100,000 robotic systems that get deployed by the end of a decade, right? So that's a large number. And from that point of view, we need to actually understand why this is important, right? So especially in Australia, this is a critical aspect, but it's also a global aspect. We don't know how to secure our supply chains, right? So that's a sovereign capability that's becoming more and more crucial. At the same time, there's more than like 2 billion people, according to the UN, that are in suffering from food insecurity. So like, especially in the food supply chain, there's a massive gap. With a recent EY study, 26,000 jobs right now unfilled in agriculture just in Australia. The Australian reported 50,000 people less that actually entered the country this year on part-time visas. So there's a significant question. And that's really the need for a robotic system. And we're not the only ones seeing that, right? So there's been a 21% growth in that. There's significant interest in trying to get our robotic systems to deliver things with no contact. I mean, outbreaks of COVID in meat processing and food manufacturing have been on the table. So how can we actually get to this point of having robotic systems out there? And again, so for us, the really high challenge is, not just building one robotic system, but thousands of robotic systems. And that's really, I think Jason hinted at that as well. I think that's sort of one of the critical aspects of it. Like, how do we, not just build one system? I don't want to sound like the academic, but like, building one system is easy. Right? You take your components, you take your hardware, you take your sensing, whether that's vision or a tightly integrated system, and you get your controller, your brain, whether that's AI or not, in the end doesn't really matter, and you stick them together, and eventually you find a way to solve the problem, right? So that's what we do as a living as academics, right? So we've done this for 50 years. So building a simple solution for a single task is not the problem, right? That's what we're good at. We know how to do that, and we've done this. What the problem is like, how do we get to this point of building thousands of these systems, because we actually have the problem of requiring 1,000 of these systems. And that's really where advanced manufacturing comes in. And I think that really is where the scale comes in, and how to sort of sticking these things together in a smart way makes a lot of sense. Another fun fact, or maybe more a sad fact, is that most robotics projects actually have more effort and resources put into them than they eventually save in efficiency gains, right? And that's really not what we want to do. That's really what we're trying at Lyra, is to do the opposite. We have internal stats that actually are directly tied to how many engineering hours do we spend per building a robotic system, because that's really critical for us. So just, that's sort of, I guess, the high level questions around that. Like, how do we do that? As I said, I came from academia. There's about a decade of the research that we did that was accidentally building the system that we're using right now by just having a lot of different students playing around with lots of different robots. And that means lots of different sensor systems, lots of different hardware systems. My specialty is about picking and packing from visual feedback. So a lot of grasping system, how do we build them? And so over the decades, we built AI systems that can be applied to lots of different multiple industries, whether that's a simple grasping task, a packing task, whether it's a manufacturing task. In the end, as an academic, you build lots of these different tools. And if you think about it, there's lots of different modules. And the same thing with the camera systems or the sensing system in general. We're talking also about touch sensors and so forth. So that's really something that we've tried to sort of build different modules over the last, as I said, decade. The point is, like, now we have all these modules, but like, how do we put them together? And that's sort of really the effort that we did at Lyra, and sort of, where we started with Lyra was the win of the Amazon Robotics Challenge. And we brought these systems actually together into one coherent system that allowed us to be significantly better than anybody else in the competition. And the competition was fierce. I mean, there was MIT, Princeton, Panasonic, Toshiba, University of Tokyo. So that's not small names, but we still managed to build a system that is significantly better. We scored, almost 20% better than the second place team. Not a lot of teams actually scored even. And we did so at a significant lower cost. The second place team was probably like 5x more expensive, but there was also a team from Japan that has at least 25x more on pure hardware than we spent. So again, the point is, like, how do we think about this problem so it actually can scale up? And reducing the complexity and reducing the price on the hardware is clearly one part of the problem. So what did we do at Lyra in the last 12 months? We actually built the world's first fresh produce pattern packing robotic system. When we say build, what that means is we developed it, we designed the system parts, and we deployed it. So on the bottom there, you can see packing avocados, but actually the system itself is, it's not a solution for avocado packing. It is a solution for fresh produce packing. We do the same thing with mangoes. We've packed, lemon, limes, passion fruit, pineapple tops recently, chilies. So there's quite a lot of different things that we can do. And that's really, for us, the core is we can change these modules really quickly, and that allows us to actually do that. We call it Lyra Machine Intelligence, and that's sort of brain, the eyes, and the hand, and bringing these things together. That thing doesn't have to work in our robot, right? It can actually work with a Haddington arm, and there's a picture of a Haddington arm down there. The third picture in the row is Dexter. Thanks, Jason. But also it works, so the white arm is a competitor of Jason. It's a Kinova arm. So we are pretty agnostic to the robotic system that we are actually working with. And that's really the other critical aspect is if you want to get at scale, you have to have certain flexibilities in it, because not every task is exactly the same. What we want to hit is 90% of a lot of tasks and then spend a bit of time to engineering for the specific solution. That's fine, that will always be the case, but it's not the point of like, just solving everything once and for all. But with that said, manufacturing is clearly a critical problem, and I want to spend a bit more time on that one. I like, so Jason and I have discussed about this before, and I like the idea of microfactories. And one of the things that we do, we build a robotic system that is highly uncomplicated. And there's multiple reasons for it. We started thinking about, we want to build 100,000 of these robots, or maybe 50,000 of our own robots and 50,000 of a third-party robot, sure, but we want to build thousands of them. So how do we get these things into the manufacturing process? How do you think about building these things up? You can't be using the latest technology or latest materials because you can't actually scale up to that. What you can use is using advanced manufacturing like 3D printing to prototype and showcase what works, and then reduce it to the least amount of parts that are moving around to get to a manufacturing point where that makes sense. And our robotic systems, as you see some sketches there on the side, but in the end, it's a very box-like system, and then there's a reason for it, because we can actually build it in a 4 square meter area. We just use a bit of aluminum extrusions, buy a few motors, stick it together, and we can build it very quickly. We've built multiple generations of these robotic systems in the last 12 months, and we're raising currently money to build more of them. But the point is, building a lot of these non-high degree of freedom robots is actually something that can be, as Jason mentioned before, done in the regions. It can actually be done where it's needed to be done. You don't want to have all these robotic systems just built in Brisbane and then shipped out all over the world. That's, I think, the 20th century thinking. 21st century thinking is you build the robots where you need them. That really requires that you actually have I guess a distributed supply chain where the parts arrive where you need to assemble them, meaning they can't be very complex, hard to source parts. The other interesting thing is, at some point we actually, Jason mentioned it too, we actually want our robotic systems to assemble themselves, right? That's really the end goal, is like you don't get to that if you don't get to the point where you're thinking about these solutions. And we're not the first ones to think about that, and probably not even Jason is the first one to think about it. I think the first time I heard that is like a couple of decades ago. But that's always been sort of the holy grail of robotics, but it has really not happened yet. And a few reasons for that are about the complexity of manufacturing. So really trying to solve that problem with that, I think, is going to be critical. And the other thing about a modular approach that we're having is it actually allows us to be highly flexible. We can change the design of the robotic system. We can make it, an S, an M, or an L robot, depending on what we're picking. We can make it, 2 wide or 3 wide, depending if we are packing multiple boxes at the same time. And we so can be really flexible on the throughput that is actually, provided to us from the external system that we're interfacing with. And I think one other thing that is sort of like critical to that aspect is also how do you actually iterate through your designs very quickly. And I think that's tied into rapid prototyping, which sort of originally additive manufacturing was one of the key components or the key pushes for. And in software engineering, a lot of people call that DevOps. So you have the development side on one thing and the operation side on the other one. We call it DVDP. It's basically develop and deploy. And the idea is that we develop a robotic system that is, doing a certain job of the task that's needing to be done. But instead of building the whole system, spending lots of time, lots of engineering hours in solving all tiny problems, we throw it out there probably a bit prematurely and deploy it and see what happens, see what we can learn from the deployment, see what we can improve, what data we can get back, and both use the data for our internal improvements as well as the improvement of the AI systems. And I think that's critical to getting to the stage where you actually have a robust system of 1,000 robots out there or 100,000 robots. And for me, the growth from 1,000 to 100,000 is really depending on getting better at what you do. And so that's where that data and that continuous deployment and continuous improvement of the deployed robotic systems is going to be crucial. I'm going to leave it here. I'm happy to take some questions on that one. Also, feel free to reach out if you have any questions or any other ideas that you want to discuss robots with. Always happy to talk robots. And again, thanks, Victor, for organizing it.
Thank you, Yuxi. Can I ask you to make Tony the admin? That way he can also turn his camera on. Let's see how that works.
Hey, Victor.
There you go. I can hear you, Tony. How's it
Can
going?
you hear me? Good. I'm restricted, but that's all right.
Just give me a second. For some reason, I can't click on you here.
You should be able to right-click on it, and he should appear as make him as an admin. Well, let's see if I have control.
For some reason, I can't click on it right now.
Can you do that back to me, Yuxi?
I can't click on anything right now.
Oh, okay.
For some reason, my user interface of Zoom just crashed. Sorry about that.
Someone else is the.
Thanks for that.
No.
Tony should be close now.
We've got the admin now. I think.
There we are.
There you go. Hi, Tony. You can see you properly now. So, as you obviously, we've had a bit of a quite a wide range of case studies and examples in additive and robotics and vision in combination of systems to actually execute upon some kind of manufacturing processes. Tony, you come from the CAD background. There's obviously a lot of importance to have that part of the system well defined beforehand. And I'm sure you have a lot of clients that are interfacing between the digital, creating twins, engaging with the equipment. So please let us know a bit of your experience in advanced manufacturing.
All right. Let's see if this works. Share. What's going to work for me? Oh, there we go. All right, so my name is Tony Ho. I'm with CAD Space.
Sorry, Tony, it's not sharing the screen. No?
Oh, it's not sharing? Hold on. Okay, let's see if I go back. There, how's that?
But working now.
Okay,
Yep.
let me start that. There, how's that? Okay, there we go. That's better.
And
So,
you have your notes showing at the moment as well. So.
Oops, hold on.
If you hover over display settings at the top, you're then able to change the screens. That's what I had to do. That's how I know.
Okay.
So if you go back into full screen mode, full presentation mode.
Sorry about this, guys. Sorry, I'm in the share side. Should we just go back to that one? Share two. Okay. Is that better? Is that just the one screen now? I think I lost everyone.
Oh, good. Yes.
Good now? You just got the one screen?
Yes.
Okay, fantastic. So, yeah, my name's Tony Ho. I'm with CAD Space. So we are actually a national SolidWorks provider. And yes, I guess that's where SolidWorks fits in, is right at the very beginning of everything. And we basically help out everyone trying to, I guess, get into that design side, into manufacturing, and straight into to the customer end user. Now, SolidWorks, a lot of you guys have already seen around. It's been around for a very long time. We have over 5 million users globally. You're talking almost 300,000 companies that actually use it. And look, there's a lot of different types of CAD packages out there, but one thing that you find that's very dominant about SolidWorks is there's a lot of automation within it. So the people that are actually just, I guess, starting out, that come to ARC, actually look at different packages that can actually assist them. And that's where, I guess, SolidWorks we want to introduce to you. So what we do is just a little bit of background on CAD Space. We are a national full-service CAD provider since 2013, and we provide the full suite. So right from your basic CAD to simulation, to also manage composer, inspection, MBD, and electrical. Now, I won't go into all the different things, but I just want to touch on that. But we also do all the training and support. So we are quite unique because we only provide SolidWorks, unlike I guess other VARs. which is value-added resellers for SolidWorks. And that means our specialist technicians only deal with SolidWorks, and you have direct access. We work with companies like Qantas, CSIRO, DoD, and Electrolux, Box, Stramit. And these days, actually it's been quite good that we've been dealing with is actually the aerospace industry as well. So we have companies like Gilmore Space that has been very active in the aerospace side and has accomplished some great things that are actually heading up using SolidWorks as well. Now, also, sorry, like the different types of industries, as I mentioned, aerospace, your consumer products, industrial equipment, life sciences, process and plant equipment, construction, high tech, alternative energy, engineering services, and automotive. So with SolidWorks, especially with hardware, you're looking at designing products, but trying to get efficiencies out of your products. You'll be able to not only design faster with SolidWorks, but also be able to do a lot more by actually innovating as well. Basically, we want you to be able to streamline your processes. Your typical processes are you start with your concepts, then you do your designs, electrical and mechanical, then you validate your designs, technical communication, and then your quality and manufacturing. Now, what SolidWorks does is it actually helps you guys compress all that. So that way you can actually save time and cost, of course, and also improve your quality that everyone's also talking about. So it's basically speed to market that you're looking to get, and also your project data management. Now, that's something that we've had actually a lot of demand lately as well, because Industry 4.0, everyone is trying to automate, hence robotics as well, that is at the top of everyone's mind at the moment. It's about automating anything that you can. And in SolidWorks, it's not just a design tool, it's about also automating all your processes, downstream documentation. So that means even your basic things that you actually have for creating things like DWGs, DXFs, straight down to your laser cutters, plasma cutters, step files to be created for your 3D printing and all your CNC. So all these things can actually save you a lot of time and essentially money, but probably more importantly, it can actually help mitigate mistakes. So what SolidWorks can do is actually not just help you in that design side, but also help automate all your different types of document management. So that way you don't have to pay your engineers and designers to be able to do, I guess, the mundane task of actually outputting drawings. So this way you can actually have things like revision control within PD, what we call PDM. Sorry, excuse me, PDM. So what that does is you can actually manage your entire business with using product data management. Now, so it basically gives you an integrated design platform to be able to have all your different components. So we're talking SolidWorks, actually. Well, you can actually do everything from your electrical to simulation and also Composer. And we also have things like eDrawing and also MBD and now also CAM. Now, one of the things that what everyone's talking about, especially in the robotic side, SolidWorks is a mechanical package, but has actually made great strides in electrical lately. And SolidWorks electrical comes in 2D and 3D. So it actually allows you to be able to do full schematics that actually work bidirectionally with your 3D electrical as well. And the two allows you to be able to do all your pipe routing and electrical routing all together. and that actually links up to your mechanical modeling as well. So that way you can actually have one platform for all your mechanical and electrical designs. So SOLIDWORKS basically makes it easier for you to bring all your ideas together. It's very intuitive, very powerful. The idea is to be able to create high quality 2D drawings and also be able to reuse any of your 2D or 3D data using your PDM as well. So this way it saves you time from having to search for any information. You can actually search through using your PDM vault to give you more efficiencies as well. So as I mentioned, the electrical design basically simplifies your development of embedding electrical systems, purpose-built tools, electrical schematic, 3D, electrical professional. So we have a few different packages, but as you can see on the side, we also can, oops, sorry about that. Okay, it's full, as I mentioned, it fully integrates your SOLIDWORKS CAD together in real time so that you can synchronize your 3D technology together in situ with all your harness development. Now, as I mentioned about communication, you actually have things like SOLIDWORKS Composer that actually allows you to be able to communicate and create manuals, technical manuals for all your different customers. And also you have your associated reuse of all your SOLIDWORKS data. And now your SOLIDWORKS data will also link to all your different manuals as well. So as you develop and change anything in your model, those changes will actually happen within Composer itself. Then you can also, with Composer to communicate, you can actually render out and have photorealistic images, so that way you can take it to market quickly. And these days you can also eliminate printing drawings using MBD, because you can output with dimensions out to the floor very quickly. And also we have bolt-ons like SOLIDWORKS inspection as well, so you can automate inspection of documents. What was added, we also have CAM as well. So you actually have CAM ability for 2.5 axes milling and 2 axis turning built into your SOLIDWORKS now as well. So essentially, SOLIDWORKS is about transforming and innovating into your success. So the idea behind SOLIDWORKS is to give you a fully integrated design program, and also has a very strong community for support with over 2 million community users. You also have a local support in every state and also training available. Also, you have educational organizations and graduates, and your goal, and basically your goals are our priority. And we want to sit down with you and actually go through your different processes, and love the opportunity to be able to help your business grow, and also for you to get the most you can out of your SOLIDWORKS as well. So these are just some of the local companies that actually use SOLIDWORKS, and as you can see, there's a very good cross section of what you have. Everyone from building simple fences to piles to automotive to aerospace.
Thank you, Tony. What's your, there are a lot of companies adopting CAD and incorporating them in their systems. Out of your clients, what are the success stories around advanced manufacturing that you've seen specifically, and in what way have they applied the tech and leveraged your system?
Well, actually, I have a company that has actually come in. They're actually called Thought Provoking, and they build actually extrusion machines, and they actually build and ship out into Europe. And how, I guess, SolidWorks actually works very well with them is they came here wanting to be able to design, but also automate everything. So one of their issues is they need to be able to connect everything, because the extrusion machines, you have furnaces and everything is automated. So that means they need mechanical design, which SolidWorks easily solves for them. But then there's electrical, there's hydraulics, and also ovens and all the documentation. So one of the big criteria that they had was they do not want people manually doing things that they don't have to. So we have actually introduced to them the PDM vault. So everything that they create, it actually goes into their vault. So we set up their actual workflow, and then their workflow flows down. So as they design things, it has to go through approval processes. And then once everything's approved, they don't actually have to touch it again, because their documentation is actually all automated. So what that does is it actually spits out all their DXFs, goes to their laser cutters, their step files, IGES files go to their CNCs, and whatever needs to be 3D printed. Same with their electrical, all their electrical harnessing and schematics are drawn up separately, and you have people setting up all their routing, because all their equipment, there's a lot of moving components. They actually preset all their routing using electrical 3D, and someone designs the schematics and harnesses so they can build them on the workbench and then bring them in. And then they can also they also use simulation as well to be able to do thermal testing, and collision detection is built into the mechanical software already. But that actually helps them streamline and stay competitive, because they want to run lean like most businesses as well.
That's great. Tony, would you mind making me, if you right click on my screen, you should be able to make me admin again.
Yeah.
If that's correct. We've got a couple of questions, and I have a couple as well that I want to squeeze in before we wrap up. Some of these questions have been answered already, but I'll just get quickly, I'll just reread them quickly for everyone else, for also the benefit of the stream as we're recording. And I'd love to hear the answers once again from the panelists. There was a question from Eddie for Ben, asking, attaching heads on the Dexter HDI, like for example a plasma cutter router, or an FFF 3D printer, so using a fused filament deposition method, will create a payload. Will it cause the head to shake when it changes direction? And if you can give Ben, I saw your answer there, but an overview of what happens when you add a payload to the system.
Sure. Sorry, my video is off and I can't turn it back on. But yeah, basically, so what it's doing when it vibrates at the end is that, I mean, every robot has got compliance in it, and particularly when you're moving from a point to another point really fast, and you've got a sudden stop, then it's going to overshoot a little bit. So how the control system works is that all of that overshooting and vibration is seen within the system, and it's accounted for, and so eventually the robot will return to a point within 25 micron repeatability. But this can be a challenge if you've got processes that you need to control the speed of the tip with great precision at all times throughout the path. I guess the application there is more difficult to achieve, and you are actually able to generate smooth path profiles using custom software. And I think Haddington have developed some software where they can generate paths from DXF files, and you can use those to minimize the vibration because you don't have jolting stopping and starting. But if you're generating a vibration at the tip with a tool, then it's going to be very difficult, particularly with the lightweight robot, because it's so compliant. It's going to be difficult to control that tip with great precision. And so, as I've said in my answer, if you have non-contact processes such as laser engraving or potentially the plasma cutting, where you're not creating that vibration with a physical contact between the workpiece and the tool, then it might be more realistic to achieve, higher levels of precision.
Yeah, no, thanks for that. It makes sense. And one of the key things I want to point out, and hopefully for everyone listening here, and then we'll be listening in the future, there's a variety of tools and applications, and it's very, very hard to find the one that fits all. There's ways in which some kind of products can try to be as flexible as possible, but as been said, for certain application, a collaborative robot like the Dexter might be perfect in a more industrial setting where you have to, you have more vibration or load, then you need different requirements. But then it's less nimble and less easy to manage and control and also program. So there's also always a little balancing act, and this is why it's really important to try to take the research properly and engage with professionals like our panelists here, and why also ARC is around to help identify the best pathway. We had another question. Here it is from Ross with two UXI around the preferred mechanism to interface with the various robots. You all answered that, but if you want to elaborate on what is that system and why?
Yeah, so the question also was more specifically about the robot operating system, or ROS, which is a commonly used, at least in research and more in industry, commonly used middleware that allows you to abstract certain capabilities of a robotic system. And obviously that makes life easier. So yes, we do use ROS when we can, but there's certain robots that don't have a ROS interface yet, or certain robots that by design or for origin of the design do not have a ROS interface. They have other interfaces. So generally we try to be flexible enough. We do build our own abstraction or modularization around some of these modules. ROS is for software. The same thing counts for hardware, right? You still want to abstract your hardware as well, so you can actually swap out one gripper for another one, or one camera system for another one. So there's also hardware abstractions that we have. So yes, ROS helps, but in the end, I think it sort of resonates with what Victor said before. There's not one solution that fits everything, right? So we'd be aiming for that. The general purpose robots, the Rosie that deals with everything that we throw at her, is still what we have in mind when we talk to roboticists in academia, but that's not what industry wants, or what we can have in industry, at least not for another decade.
Yeah, great, thank you for that. I have another more key question, as if anyone wants to sneak another one in before we wrap this up, but it mostly revolves around the main mistakes that companies adopting advanced manufacturing make. And this is something I want to go around, whether it's rushing into it or not rushing, or not doing their research, or underestimating some components. So I'll start with you, Stephen, and I'll go around. I'd love for you to point out probably the top one, if you can do it quite briefly, please let us know.
Yeah, sure. Look, there's always a benefit of going first, and there's obviously downsides of doing that as well. My honest opinion is that being a first mover is going to give you a lot more of an advantage. It's possibly not necessarily going to show a return on investment immediately, but I do think that if everybody jumps on board, which I think we're seeing with additive manufacturing now, and we're seeing with specifically with Mark Forged, that there are big advantages of moving first and being a first mover. So I think with that in mind, I would say, think about applications within individual businesses that that may be relevant for 3D printing and come and talk to us, and we can have that discussion. And if the solution's right for the problem, then we can do something. And if not, then we can, then at least we've asked the question. That's probably what I would say in the briefest way. You're muted, Victor.
Thank you, Stephen. Jason, one of the main mistakes that you've seen companies kind of face when at least considering advanced manufacturing? You're muted now, Jason. There you go.
Sorry about that. Same mistake. I think the main mistake people do is just waiting until someone else does it first. I mean, it seems to be there's a lot of time wait, and Stephen will probably become this. There's a lot of tire kicking done out there, and it's great. Listen, it's great. We go out there. We like to share the knowledge. We know about 3D printing or CAD or whatever it is. Simulations that are going to make your business better. But there tends to be, a lot of people that really will take that information in and wait for someone else to do it. And then it's too late. You've as Stephen says, that first mover advantage is certainly a good one. Now I'm going to put a proviso on that, and that jumping into some crazy new thing is not what I'm suggesting, but I'm certainly suggesting that there's a way that people can really assess their needs and wants. Ben gave a fantastic assessment of how to really go through that in a sort of a programmed way of eliminating, and accepting that there's potential failures as well. But I just like to see more people jumping in, especially in Australia. I'm one of those people who've been pushing technology here for a long time and have finally had to go to America to do something. And I don't want that to continue. We brought a MICROFACTORY back in this case, and I think Australia and especially Queensland, there's a buzz in Queensland that this place could be the next Silicon Valley. Who knows? But I'm certainly one of those people that are a big Queenslander these days.
Amanda, from your perspective with some of your clients, what are some of those concerns and mistakes that you've seen?
Look, I think when it comes down to it, early adopters are generally the people who have put in place some foresight about what they're going to do. But going around actually spending time in the industry, you see a lot of wastage. It's my opinion that there's been a bit of a shotgun method, perhaps in the last generation of robots before we got to the cobot stage. And there is certainly materials that haven't been well integrated into what the business is actually doing. Fundamentally, I think the number one error is that people aren't really considering the utility of what they're doing. They have to have a very secure business plan. They have to know what their budget is. They have to understand whether this machine is actually going to make the improvements. So doing a proper efficiency analysis, and then having the ability to wait on that return on investment, which is only within probably 4 to 5 years. But when we're talking small business, that can be a very long wait. So I would say that the number one error is wastage. People engaging in things and then finding out that it wasn't actually suitable, which is a massive shame, because the wastage isn't just in technology, but it's also in people's skill sets as well. So I would say that's probably what I would identify, Victor.
Thank you, Amanda, and I'll leave my comments for last. Ben, from your perspective, a quick.
Yeah, I think similar to what Amanda's saying, I've seen a few projects all over when, in terms of evaluating a budget. I think it's really crucial to be open about what or know what your budget expectations are before you go into a project, because it can really help speed up the process of figuring out what is actually within someone's budget. Because an automation solution often it could be as expensive, could be $1 million or $100,000, depending on what inclusions you want to put in there. And from my perspective, I'm not in the business of trying to rip people off. It's just I think it's better to be open about your budget early on, and so that way we can be realistic about it, and give you something that hopefully, you know, improves your production processes, but it's also affordable, and we can take those factors into account in our design early on. I think that's pretty important.
Thank you, Ben. Yuxi.
Yeah, I guess a lot of the stuff that's been said resonates with me. I think the only thing that I might want to add or put more emphasis on is, I think people are just not thinking large enough. There's a certain amount of, like, you know, tire kicking, as Jason says it, or, you know, people just exploring little options. It's partly natural to overestimate the short term and underestimate the long term. That's yeah, what we do as people. But a lot of people are not seeing the full picture and seem to be scared about large, you know, going large into advanced manufacturing or even advanced technologies. Whether that is manufacturing or not doesn't in the end matter. I think it's a massive opportunity, and it seems we are a bit sluggish here in Australia when it comes to the uptake of that.
Thank you, Yuxi. Tony.
I have to definitely agree with everyone that planning is crucial, and foresight is the other side. Because in Australia, yeah, it has struggled quite a bit. But one thing that we have seen recently with COVID has actually made people have no choice but to manufacture here in Australia. So people have actually taken a great attention to looking at manufacturing and automating and advanced manufacturing. There's a lot of grants out there. We've actually been very, very busy due to that, but also, as I was talking about planning, it's automating anything they can to be able to be competitive with China, India, anywhere else in the world. And Queensland has been doing a very, very good job. And also nationally, we've been seeing a lot of that. So it is, if you guys want to chat, anyone wants to, about starting from, I guess, the ground up, which is your design, because in the overall process, 25% is design, 75% of it is the execution and delivery of the manufacturing of your product and how you get efficiencies. That's where our profit sits. So planning, and definitely we can always find a budget, I guess, a solution to fit the budget. And that's what I think everyone wants to try to do.
Thanks, Tony. And just to wrap things up, and then we're pretty much on the mark. I think it comes down to, think big, be open to it, and do your research. The numbers, if they add up, they add up. Make sure that the area you're addressing, the area you want to automate, look at what it's currently costing you, look at what the time it's taking, and look at how a variety of technologies, if properly implemented, can actually optimize that process. And then you'll see a trajectory, you'll see an opportunity to get that return on investment. As I mentioned before, there's not one solution that addresses everything, and it is, in most cases, a custom scenario where you're combining the design with the robotics, with the additive or subtractive manufacturing, with the vision. And so it's about bringing and being aware, not being overwhelmed by this variety. It's there. It's not too complicated if done properly. But with that, I'll wrap things up. A big thanks to all the panelists today and the speakers. We will have this recording available. I think it might have also been streamed on our social media during this presentation. If anyone has any further questions, would like to get in touch with the panelists, obviously we share their details, but also feel free to get in touch with myself and Ark, and we'll happily put you in contact. Thank you everybody for your time. I know it's been a long week and it's been a very interesting year, but in the scheme of things, in the area of advanced manufacturing, it's been a very pivotal year. So this is really the beginning, and there's going to be a lot more focus in this area. Thank you very much to all. Enjoy your rest of the week and weekend, and thank you everyone for attending.
Thanks for organizing, Victor.
Thank you. Bye-bye.
Thanks.
Thanks, Victor. Bye-bye.
Thanks, Victor.
Bye.
Bye.